sorry. Let's go back to where we were. So we know that, since we know that the cosine squared theta plus sine squared theta is equal to 1. Hold on. Okay. That means we know that the sine squared theta is equal to 1 minus cos squared theta. Right? So we can say this is equal to sine of 1 minus cosine theta over sine squared theta and then we can simplify this and say this is, we can cancel one of the signs with one of the signs and we get, sorry I don't have any space, 1 minus cosine theta over sine theta. Okay? Any questions? All right. I don't understand the question, Siobhan.
What you just wrote down, that goes towards the previous stuff that we were writing down before?
It just goes, this equals this, and then this equals this. This is separate. This is separate.
Okay.
It goes in order. The sine of theta times 1 minus cosine theta, this part, so here, let me, hold on. So this becomes that.
Got it.
Does that make sense?
Yep.
Okay. Okay, so if I have this, if I have A here and I want a common denominator, what do I do? How do I get a common denominator here? Yeah, so I multiply this times I multiply this times 1 plus sine theta over 1 plus sine theta. And then I multiply this by one minus sine theta over 1 minus sine theta, right? And I get 1 plus sine theta over, I'll just do the whole numerator and then, because just for space, and then I have plus 1 minus sine theta over the common denominator 1 plus sine theta times 1 minus sine theta. Does that make sense? I know it's kind of mushing together. I'll use the bottom as well. So here I have 2. This plus sign theta and the minus sign theta cancel, and I get 2 over 1 plus sine theta times 1 minus sine theta. Is everybody with me? Okay, so this becomes 2 over 1 minus sine squared theta. And 1 minus sine squared theta is the same as what? Cosine squared theta. And then I can just turn it into secant squared theta. Okay? Good? All right. I'm not going to do B, just what's the matter, Jackson? Okay, no problem. Take a second. You got it? Okay. Okay, so now we're going to try to make something equal to something. Hold on one sec. So we're going to try to, so there's a couple of different kinds of problems in ALEKS, and maybe we'll do some ALEKS. Let's just get through some of these on our own first, and then I'll show you what ALEKS wants. So the first thing we're going to do, whenever we have these identities, the best place to start is always turning everything into sines and cosines. It's not always the only way, but usually, I would say 90% of the time it's the best way. So what I'm going to do is I'm going to say this is equal to sine theta, and then cotangent theta is equal to cosine theta over sine theta. And then tangent theta is equal to sine theta over cosine theta. Right? Okay, good. Now, here's a couple of things that you should just look at and notice. I have something times something plus something on the left, and on the right I just have one function, notice. So somehow I need to get that plus to disappear, don't I? So to do that I need to make one fraction. And the best way to make one fraction is what? Or how about the only way to make one fraction is what? Not exactly. Yeah, I need a common denominator. Right? I just need a common denominator. So what's my common denominator? It's sine cosine. So I can say this is equal to sine theta times, and my common denominator is going to equal sine theta cos theta. Right? Okay, good. So to get that in the first part, I'm going to multiply by cosine over cosine. So I get cosine squared theta. And in the second fraction, I'm going to multiply by sine over sine. So I get sine squared theta. Right? Okay, good. Now what can I do here? What do I know? Tell me something I can do. Anything. There's a couple of things. I want to simplify. Good. Yes. So I know that cosine squared theta plus sine squared theta equals 1. Good. So I now have sine theta times 1, obviously, over sine theta cosine theta. Now what? So I can cancel the signs, exactly. So I end up with 1 over cosine theta. And what is 1 over cosine theta equal to? Secant theta. Look, that's what I was supposed to show. Any questions? Okay, now we're going to do the next one, but we're going to do it, and we're going to try to tell the reasons for it. Now, there's a few reasons that Alex will give you. One of them is algebra. Sometimes the reason we're doing something is just because we can do it with algebra. Sometimes it's quotient. I'll tell you what the differences are. Sometimes it's reciprocal. Sometimes it's Pythagorean. And I think you also have an option of odd, odd-even. So these are the different things options we have. So the first thing I want to do is what? Don't worry, we'll get to it when we get to it. We can't use it until, it's the same as I just showed you with odd and even, but unless the problem calls for it, you don't need it yet. I just went over odd and even functions, Timothy. Remember? Like probably about 15 minutes ago. It's okay, no problem. So what's the first thing? Well, don't anybody answer. I'm going to start going back down my list. Let's see. I left off, I think Rio is next. So Rio, what's the next thing I can do here? Well, the first thing I can do here. Not the next thing. First thing. Good, exactly. I'll change everything to sine and cosines. So cosecant is what? Good. 1 over sine. Okay, so now if I was in Alex, I can't really do anything more because if I change the cotangent, so changing the cosecant to 1 over sine is the reciprocal rule, right? Reciprocals are 1 over something. Is everybody with me? Okay, but if I change the cotangent, is that the reciprocal rule? It's not, because it's not 1 over. The cotangent would be the quotient rule. So I'd have to do 2 steps. So I'll just do it like I would have. I'll try to do it. It's going to take a little longer. So I can change this to this because of the reciprocal rule. Okay? And then I can do the next step. So Rio, what is cotangent? Good. Cosine over sine. Now, that would be called the quotient rule because it's a quotient, something divided by something, right? Okay, so we're on our way. what's the next thing I can do here? Any ideas? Rio? Siobhan, you can have the next one. I promise. Next one's all yours. Yeah, and I can do that because I have a common denominator, so I get 1 minus cosine theta over sine theta. And what of those rules do you think would work for this? What allows me to combine those? It's the easiest answer. It's just algebra. Most of the things we're going to do are algebra. Almost like probably in all of these problems, you'll do a little bit of trigonometry. Most of it will be algebra. Okay? So we're here, but we want to make it look like this. So I know that this is probably putting you on the spot, but let's try first Rio, and if not, I'll go to Siobhan. So Rio, do you have any idea how I can start making this look like what's on the right-hand side? If you don't understand, that's fine. This is pretty new. Yeah, there is. Do you have any idea what I could do to make that happen? It's not really an identity. I'll give you a clue. It's algebra. It's a little bit of algebra, a little bit of trig. Do you know what to do next, Siobhan? Okay, does anybody know? I'll just open it up to everybody. Okay, Michael, what do you think? Not the reciprocal. Yeah, so that's called the conjugate. You multiply by the conjugate. So we multiply No, we don't do that. We multiply by the conjugate. And we get, so what's 1 minus cosine theta times 1 plus cosine theta? It's just the difference of squares, right? So this becomes 1 minus cosine squared theta over, and don't combine things right away. Keep everything factored as much as possible until you need it to be multiplied. So is everybody with me so far? So, and this would be just algebra, right? Okay. So now, what's the next step? Do you have any ideas, Rio, since I have it at you? It's okay if you don't. I'll just take Louis. You do the Pythagorean. So what do we do, Luis, what do I do with Pythagorean identity? Yes. I know 1 minus cos squared is equal to sine squared. Perfect. And I'm not going to write it, but this would be, well, I'll write it, Pythagorean. That's the reason I can do that. And then next, I'll just take it from here. we can cancel one of the signs with one of the signs, and I get sine theta over 1 plus cosine theta. That would be because of algebra, and that's what I wanted to show. Is everybody starting to get this a little bit? All right, good. All right, let's go on.